So, doctor, tell us a little bit about what happens to our brain when we are sleeping.
Yeah. So when we are sleeping, what happens is your active, inputs which you're getting, right? Inputs from your vision, inputs from your senses are all temporarily suspended. Okay. So because of that, the stimuli which is keeping the brain attentive is cut down. Okay. So once that the stimulus is cut down, eventually what happens is there will be the activity of the brain, the processing of the brain, all those things slowly come down, and then you reach a level of slow wave pattern, and then you slip off to sleep. So what happens is your active centers, which have been active most of the day, will take a break basically. In that break, the whatever metabolites, the byproducts of the energy being utilized and all that activity are being slowly flushed away from the system.
So, the metabolites are what generally people refer to as toxins.
Yeah.
And so, do you think that byproducts or metabolites is a better word to refer to
byproducts
that?
of metabolism is a better word,
Okay.
rather than saying toxins.
And what else happens? Like, what are these metabolites, or why are they getting created, and how do they get purged?
So metabolites, see, whenever there is a particular activity happening, I'll give you an example of in the brain. The brain cell membrane is a membrane which has a potential difference of electricity. Okay. So that
voltage.
Potential difference of voltage. That's potential difference is there.
Yeah.
So the potential difference is called resting membrane potential, RMP.
Okay.
Okay. So that particular RMP is supposed to be minus 70 millivolts.
Okay.
Okay. And that RMP is maintained through a particular particular part from on the cell membrane. Okay. It's called a NAK ATPase channel. Na means sodium,
okay.
K is potassium, ATPase. ATP means ATP is the fuel of the cell.
Okay.
The unit of
adenosine triphosphate.
Yes. Glucose is fuel, what you say, but actually glucose can convert it to ATP. So ATP is the most basic fuel of the cell. And so NAK ATPase is the channel through which the body actively purges out sodium from the cell and brings in potassium into the cell to maintain the resting membrane potential. So when you are actively engaged in activity, all from in the morning and whenever you are active, this RMP, the potential keeps fluctuating. Eventually from minus 70, it may get into minus 50 or minus 40. So then what happens is the function which ensues, if when there is a RMP which is not correct, not ideal, it will be definitely not that good. The whatever ensuing function will not be that good.
Yeah.
So in order to bring it back, it needs that little time to bring it back to normalcy.
See, you gave you gave an example of a restaurant kitchen.
Yes.
Could you please repeat that?
So that was in the sense. So relaxation and repair happens as we speak. But what happens is when we are, like, say we are morning, when we are having say 8 hours of a kitchen which is open for 8 hours, and then you start making a first dish, and then though you're making the dish and you're still trying to clean it up and then put it back. No matter how efficiently you can do it, you still have some amount of spillage of this clutter into the kitchen.
Yeah.
Okay. So eventually after a period of 8 hours, there will be a significant amount of clutter which needs to be put back down into its position. So that's the thing.
And while the kitchen is working, that cannot happen because then it will reduce the efficiency
of the kitchen. So that's why you leave it for some time later. So that's what you do eventually.
And how is this purging happening? How is this flushing happening? What is the process?
The process so what happens is basically your blood flow. Basically, the blood flow, when the blood comes in contact with the cell, everything depending on the concentration gradients of these things. For example, there's oxygen deficit at one place. So the cell has utilized oxygen, right?
Yeah.
So, and then there is more oxygen in the capillaries, blood. So, preferentially the oxygen starts diffusing more onto the cell. Okay? Because there is a gradient is there. So, because of the gradient, it goes in. Similarly, there will be, once the byproducts of metabolism start forming, there is more of that concentration in the cell than in the blood.
Yeah.
So then it starts diffusing into the blood again.
Okay.
That's
And
the
then basically your liver and your kidney are basically
Then
pulling
they
that
will
out
eventually metabolize it and throw it out of the
and throw
system.
it out of the system.
And then in this, yeah, so that's how it happens. This, when you are sleeping, what happens is the actual
Input is low.
input is not there, and also performance of that particular cell is temporarily what you call suspended. Then what happens is it can easily remove all that extra gradient of the byproducts, and then it will be again pristine, in the sense ready to start again.
So basically, you can say that sleep is the detox regime of the brain.
Yes, it is. It is not just for the brain; it is for
The rest of the
everything, the
body as well,
muscle,
so-
all the organs, definitely.
And